Okay, in this presentation I wanted to show how you would use the Andromeda Research Automotive Kit 1 or 2 to work on digital clusters. Basically what I'm going to cover is these are, I'm using initially the General Motors clusters because they are very common, and it's also very easy to see the result. With other demonstrations I've done in the past, you can see the procedure, but there's no result for you to see other than the fact that the equipment indicates that it read and programmed the part correctly. You couldn't see anything else work. Okay, well that's not the case with clusters. With clusters, assuming you have a cluster that will display mileage when it's powered up, some clusters will not because they need to be connected to the car's network in order for them to display the mileage. But the General Motors clusters in many cases are not like that. So there are many videos on YouTube on how to repair General Motors clusters. Okay, this is not, we're not going to talk about stepper motors, we're not going to talk about broken solder joints, we're not going to talk about any of those things that those other videos cover. Basically, the Andromeda Research Automotive Kits allow you to work with the memory parts that are in almost any module manufactured. Okay, so as I've shown in the other videos, ECUs, immobilizers, and other modules, we work directly with the memory part, and we work with those memory parts in circuit. Okay, so a lot of other videos show you how to unsolder the part, put it in your inexpensive USB programmer, copy it, and then resolder it. Okay, well we don't do that. We're going to work with the part in circuit, and first we're going to do something simple, which is a simple clone. And the purpose is to show you that if you have a defective cluster, bad stepper motor, maybe it does have a bad solder joint, you can't find it. If you can locate a cluster which is identical to the one that you own, which is defective, then you can just copy the data directly from the defective cluster into your target. So I'm going to show you how to do that. Okay, so first, this is a cluster out of a 2003 GMC Trailblazer. Actually, I'm not going to use this cluster as part of the demonstration. I only wanted to show you how you, there are videos that show how to take these things apart. Okay, so basically you flip it over, and I've already taken it apart. You can see the needles here in a little bag. Flip it over, here's the back. The back, there are clips that hold the back on. And then put this over here. Here's your circuit assembly. I didn't have a connector for these, so I just soldered the wires onto the appropriate points in order to get power connected to it. And then you lift it out of the assembly, and now you can work on it. Okay, so here it is, out of its assembly. All right, and what I'm going to do, here's the power connector, and I have a little 12-volt power supply that I've used to put together this demo. So let me just zoom in so you can. I'll point out some of the components that are on this so you can see them. Kind of zoomed in a little too far there. Okay, obviously your displays. Here we have the processor, your stepper motors. There's another processor. I don't know why this has. A lot of these clusters, they have multiple processors to share the different tasks. They're not just for, this may be the controller for the display. Okay, I don't know specifically. But anyway, the other thing that you need to locate in order to do this work is the eeprom. Okay, and the eeprom in this case is right here. All right, it's a little 8-pin part. They're very easy to locate. If you happen to have a GM cluster where it's got the subassembly where the components are inverted, the eeprom is on the other side of that assembly. So you would have to either determine where the connection points were on the back, which would work because we do things in circuit. You wouldn't have to unsolder it, or you would have to unsolder that assembly and flip it over. Okay, but the ones I'm going to be showing today do not have the EEPROMs are right where you can easily attach to them. Okay, so the next thing I want to do, let me zoom in close to the EEPROM so you can see the part number. Hopefully I can get it to be readable. Okay, well, it took a little bit of elevation in order to get to the point where you can actually read the part number that's on the EEPROM. And you notice at the top it says Atmel. Okay, Atmel is a manufacturer of EEPROMs, but we provide a document with our kits, which helps you locate and identify EEPROMs based on the industry standard part numbers, because that's typically what they use. Well, General Motors, GM, is notorious for putting their own inventory numbers on components, which makes it difficult to, if you just are looking at the component, difficult for you to know what the actual industry standard part number is. Anyway, there are three families of EEPROM. The 93 family is very common. Then you have the 25 and 95 family, and then you have the 24 family. Okay, well, this part number says 68558. All right, well, that is not an industry standard part number, but the actual part number is a 25020. Now, one trick that you can use is just if you find a part and you're not sure what it is, enter the part number into Google and then append to the number the term EEPROM, and then let Google search. And if somebody on the planet has determined that it's an EEPROM, you'll probably find the result, and it'll tell you the actual industry standard part number. Anyway, I wanted you to see that so you would know if you proceed. One, what the EEPROM looks like on this particular cluster. There are other GM clusters and that says 25020, but on this particular one it does not. And again, we provide a document because if you buy one of our kits, we don't leave you wondering what to do or how to do it. We give you a document in addition to our training tutorial. Our EEPROM and microcontroller identification and location document tells you all about the different part numbers, the different families, the options that we have with our products to connect to them, so you're not left without a path to success. Okay, here's the cluster back in the position where you can see the whole thing. What I'm going to do, I'm going to go ahead and power it up, and you can see what it looks like when it powers up. This is also, there's tons of videos which show this on YouTube, but I'll just show it here. Okay, powers up, and this has 281,344 miles on it. Okay, well, what we can do, and I'm not going to use this cluster to show you that because I don't have another one exactly like this. And in order for a cloning operation to work, you need to have a cluster which is identical. Although my experience in looking at the data, that the way that it's stored in the EEPROM, you can actually move the data from one cluster to another, and they don't necessarily have to be identical. It's kind of interesting. Understandably, the people that wrote the code, the team that wrote the code, probably wanted to reuse their code, so they kept the data format, storage format, and the EEPROM the same. So regardless of the shape of the circuitry or the maybe even the processor that they used, you'll find the mileage and VIN information located in the same place. So anyway, let me get the cluster that I want to use as a demo, and then we'll proceed with the cloning operation. Okay, this is my good cluster. You'll notice that the design is different than the one that I had up here previously. You can tell it's my good cluster because there's a label here that says works. All right, so I'm going to power it up, and you can see what its condition is. Doesn't have stepper motors, but you can see that its display comes on and the odometer is 196,208 miles. Okay. Now, the reason I'm showing you this is what we're going to do is we're going to transfer information, the data from a defective cluster into this cluster. Okay, but this cluster, I want you to see what the mileage is now. Okay, and now I'm going to get my defective cluster, and we will clone the data from it over to this cluster, and you'll see what the result is. Okay, this is my defective cluster. You can tell that it's defective because someone has harvested the lower display off of the circuit assembly. Well, it kind of renders it defective. But if you look over here, we have the eeprom with the mileage, VIN, and anything else still intact. Okay, you also might notice there's something here that says number 4. I have several clusters that we used for testing. Some worked, some didn't, some had issues, some did not. And we numbered them as we saved the mileage information or the data from the eeprom to files so that we wouldn't lose those in the event that we had a problem. But anyway, I'll show you how simple it is to do that, or to do this. We're just going to clone the data from this cluster, clearly defective, into the previous cluster, which clearly works, and I'll show you the results. So we don't know what the mileage is here, but we're going to find out because we're going to move the mileage information from the eeprom into the functioning cluster. Okay, I'm not going to go into how to set up the programmer and all of that. There are plenty of videos which you've done previously where you can see that. But what I do want to show you is this is our in-circuit adapter. We're going to use a clip for this demonstration, and this is an SPI part, a 25 series part. But I want to show you something else. Okay, one of the things that we have done over the years, where we have supported our product, and as we've learned of part numbers which don't actually match industry standard part numbers, we have put them in our device selection table, so our customers, if in the event that they do an odd part number, they can at least have our software scan for it and see if it's something that we support. So let me switch over. We'll start our software and get this demonstration started. Okay, let me go ahead and start our software. If you remember, I pointed out that the part number that was printed on the device itself, on the eeprom, was 68558. All right, and that's not an industry standard part number for an SPI eeprom part. However, because we have collected odd part numbers for easy cross-reference by our customers, it's actually in our device selection table. So for our customers who look at the part and go, gosh, I wonder if that's a number that's supported by the Andromeda system, you can at least have our system search and see if it's in the list. So I'm going to enter 68558, press enter, and you'll see that it is supported, and it's the same parameters as a 25020, but it just makes it a lot easier for you as a customer not to have to try to figure out what the odd number is on the part and how it references an industry standard number. Okay, so give me a minute. I'm going to put the clip on the eeprom, and then we're going to read it. Okay, here we have the clip attached to the part. Turned out that pin 1 was up in the upper right hand corner here. It was indicated by a little dimple on the device itself. So we put the clip on the part, and now we're going to read the data from the eeprom. So we're going to switch back to the computer. Going to select buffer editor, which is command 5, and we're going to press G, which is get valid data. So we're going to allow the part system to read the part, and it reads the part, indicates part and buffer match data indicates valid. Okay, so that's the data that is currently in the EEPROM on the defective cluster. So what we want to do is we want to move that data over to our working cluster. Okay, so let's go ahead and do that. Okay, make my working cluster. Here. And give me just a moment. Oh, and you don't want to do this with power applied to the cluster. You can damage the programmer, you can also damage the cluster. So you always do any kind of reading and programming with the system, the cluster powered off if you happen to have a bench power supply to power your cluster. All right, so let me hook up the clip. Okay, the clip is now attached to the functioning cluster. This is going to be our replacement, and now what we're going to do is program the data from the defective cluster into this working cluster. So I'm going to go back to the computer display. There's the data from the original cluster, the defective cluster. And now I'm just going to use a trick that I've shown you in other videos, which is the quick view command. Am I really hooked to the clip? If I am, I should see the data that's already in that EEPROM on the screen. So I'm going to press Q for quick view, and there's that data. Notice at the top of the screen it says device contents. It's a way to know that you're actually hooked to the part before you do something like, I mean, if you read the data from this part and you're not attached to it, you'll lose the data that you got from your source. So you want to be sure you're hooked up, and the quick view command lets you do that. Quick view reads first 256 bytes from the part and puts it on the screen. It does not put it in the buffer, so your original data is still intact. So key, there's the original data, and all we have to do to basically clone it is program it. So we're going to press Command 2, which is program device from buffer, and we're going to say program from buffer start. Yes. Program complete. Data verification is correct. Okay, we've now done it. You're done. So let's see what the mileage is, or was, or is in the defective cluster. So we'll flip back over to the camera, and I will hook up the power supply, and we'll see if the 162,000 miles is now changed. Okay, so let us remove the clip. Let us get the power supply, plug it in here. Unknown driver. The new mileage is 165,017. Well, that's not exactly a big change, but it's enough of a change where you can see what it was before and what it is now. So the mileage on the defective cluster was 165,017, and the mileage on the original cluster was 162 or whatever it was. So that's what I wanted to show you, is how easy it is to clone a defective cluster into a working cluster. You literally do it. We didn't unsolder any parts. We just moved the clip from one cluster to another, read it from the defective cluster, programmed it into the target cluster, and now we're finished. You can just go and put this back in the car. Put your new cluster back in the car, and you're done. Okay, the next thing I want to show you, I'm not going to do a mileage correction simply because it wasn't part of this video. This was primarily to show you how easy it is with our products to clone clusters. But I will take a moment and I'll show you how mileage is stored And we'll do just a little experiment, just a little modification to mileage. Although I don't know what the result's going to be until after I do it, because I'm not trying to change the mileage to something that I know. I'm just going to change the mileage, okay? And whatever the change is, it'll be reflected. But I want you to see perhaps how easy it is to do that. So let me flip back over to the computer screen, and here is the data that's currently in the EEPROM on the cluster that we copied. Okay. Basically, this is the data on the functioning cluster now. Mileage is stored in groups of 3. Okay, and you might ask, well, why do they do that? They do it because the worst thing that can happen with a vehicle, is true mileage unknown. Okay, that pretty much wrecks the value of the car if you don't know how many miles are on it. Okay, so what they do is they will store mileage in 3 places in the memory. All right, and if you look at the data, many times it's relatively easy to see the mileage. Okay, so you start looking for groups of bytes that are close and not close, identical in value. Okay, so let's look here. Here we have this. They happen to start at address 0 in this part, so we have a 192D. Then we go over here, and what do we find here? A 192D. Okay. Then we go down here on the second line, line 10, and what do we find? A 192D. Okay, well, why do they store it in 3 places? Because if one of these memory locations becomes corrupt, okay, if you stored your mileage in only one place, and that one place became corrupt, you would have a true mileage unknown. You'd have a mileage unknown situation. Well, they don't want that. Okay, so what will happen is, in the event that one of these 3 locations becomes corrupt, the processor will look at the 2 that are identical, and it will change the one that's corrupt back. Okay, so that you have 3. And if you have one that won't change back, all right, then the cluster will give you some kind of an error, mileage error, whatever, okay, indicating that there's a problem. However, I tell you what, let's just change some miles. Okay, I have no idea. Mileage is typically stored as a binary integer, and we have a mileage correction exercise, which is part of our training tutorial, which comes with our kit. I'm not doing that here. I'm just going to show you how easy it is to alter the data. So we have a 2D and a 2D and a 2D. Okay, and I'm going to change those 2Ds to I don't know, let's just do modify address 0, and we'll go over and change this 2D to a 55. Alright, and we'll go over here, change this 2D to a 55. And you have to change all 3 of them, otherwise the processor is going to give you an error. So we'll change this 2D to a 55. Okay, now let's write that. We only changed 2 lines, so we'll use the write command to update the EEPROM. So let's say write address 0 to address, that would be this address here, would be 1F. Okay, to 1F, and we're going to start at address 0. Right. Okay, program complete, data verified correct. Okay, well, let's see what we did. So I'm going to switch back over to the camera, and I'm going to disconnect the clip, okay, because we wrote the data to the EEPROM. Now let's power it up and see what we got. I didn't do this before, so this part of my demo flops. Well, then I guess it's why you don't always test before you do a demonstration. So let's see what we got. And driver odometer 166041. Okay, well, that's different than the 165 whatever it was before, but I was kind of hoping for a bigger change than that. So let's do it again. Let me unplug this. And I'm going to reattach the clip. Okay, reattach the clip. Go back to the computer display. And now I'm going to modify 0. But I'm not going to modify the 5.5. Let's see if the 1.9 affects the value, mileage, to a larger, in a bigger case. So let's change that to a 0.9. 0.9. 0.9. Okay. Now let's write that to the part. Write 0 to 1 to 1F. Starting at 0. Regularly data verified correct. All right. Let's see what we got this time. Overhead camera. Disconnect the clip. Plug it in. Now we have what? Driver 61,183. There we go. That's a pretty significant change. All right. So you can see that by altering the storage locations in the eeprom for the mileage, you have to alter all three. This is how you do mileage correction. All right. And as I said, we have an exercise in our training tutorial which shows you how to do that. All right, the exercise that we have is just for GM clusters. There are other mechanisms by which mileage is stored, so GM is one of the more friendly ones when it comes to changing the mileage. Okay, so there are also programs that you can get which will do mileage calculation based on the vehicle. So those are available to you. But I guess the one thing that I wanted to point out, if you have a defective cluster, the easiest solution is just to clone it. Okay, clone it into a good one, rather than dink around with changing the mileage on one that you purchased, that you got from a salvage vehicle or off eBay. Just clone it, because your defective cluster is going to have good data in its eeprom. So all you have to do is move that good data into your replacement part, and you're done. With our product, it should take you, once you get the cluster apart, probably less than 10 minutes to do that. And there's no unsoldering, no hot air tool, no lifting it off with tweezers, no flux, none of that. Clip-on, or if you want, the AccuTouch probe, which is also, I'm going to do the next part of the video, I'll show you the AccuTouch probe. You don't even have to fiddle with the clip. In the case of the GM clusters, they're very clean. It doesn't have any humidity sealant on the part. They didn't need to be, it didn't need to clean those. But with the AccuTouch probe, you don't even have to clean the humidity sealant off. Okay, well that wraps it up for this part of this video with respect to GM clusters. The next part of the video, I'm going to be doing a Volkswagen cluster. So let me get those, and you can see how that works. Not going to be as detailed as this, because the Volkswagen clusters, they don't light up. I'm just going to do a quick cloning. So you can, it's a different device, so you can see that work. Okay, for the next part of this demo, I've got two Volkswagen clusters. Okay, they're not from the same vehicle. They're not from this. They're not the same type. They're close, but they're not the same. Happened to be what I had on hand, and I just wanted to do another clone from. I mean, the first one I did was from a domestic General Motors vehicle. This is from a European vehicle, but they're similar enough in their design where you can see that the parts are the same, even though the layout of the cluster is different. The cloning operation would be the same, although you can't clone, well, you can clone the data from one to one that's different, but it's probably not going to work correctly, especially in this case, because my understanding is Volkswagen stores their security or immobilizer data in the EEPROM in the cluster. Okay, so in the event that you are cloning your defective cluster and you want your security, your key information to move with it, you have to have a cluster which is identical in the part number. Okay. So let me point out where the EEPROM is and what type it is. Okay, the EEPROM in this case is a 93C86. Okay, it's here, 93C86, and then the other one is here. They're the same. Now, the 93 family is different than the 25 family. Okay, and one way to understand, kind of assume that the security data is stored in the cluster is the size of the EEPROM. I don't mean physical size; they're all 8 pins, but storage capacity size. Okay, in the GM cluster, it was a 25020, which is a 256 byte part. Okay, the 93C86 is a 2048 byte part, so it's significantly larger in terms of the amount of memory that it stores, amount of data that it stores. Okay, doesn't mean the cloning operation isn't the same, but it's the other things that are stored in there. It's got other things stored other than mileage. All right, so that's why the designers chose a part. Matter of fact, the 93C86 is the biggest part you can get in the 93 family of EEPROM. Okay, so we need to set up our programmer to connect to this component, and let me do that, and I'll be right back. Okay, here's the programmer, and it's still set up for the General Motors cluster. So the just show you this real fast. Let me go back to the computer screen, and that's the General Motors EEPROM data. Let's get rid of that. Oops, wrong keyboard. And we're going to go back and use Command 9, which is enter device type. We're just going to change our part number to 93C86. All right, and when you do that, you'll notice that the system comes up and it tells you how to set the dip switches, which are different in this case. They're all down on the in-circuit adapter. And it says plug or device position left. So what we're going to do, I move the dip switches down. Then we're going to move the plug over to the left-hand set of headers, which is the 93 family. Remember I said there's 3 families? 93 family, 25, 95 family, and 24 family. So the Volkswagen clusters, 93C86, so we're going to use the left-hand set of headers. Okay, so let's go ahead and hook up to the clusters, and or the first cluster, and we'll get it cloned. Okay, I did a bit of a change up on you. I said before I would use the AccuTouch probe instead of the clip, so I just replaced the clip with the AccuTouch probe. This is the AccuTouch probe. The AccuTouch probe is a lot more convenient than the clip. It doesn't come with our kits. You have to buy it extra. But it makes working with 8-pin EEPROMs in circuit a lot easier. Okay, and the way that it works is you just push it over the top of the part like this. You just line it up and you push it down. Okay, can't see it because my fingers are in the way, but you just line up the little spring-loaded 4-point crown gold-plated pins with the appropriate legs on the part, and then you hold it there while you use your other hand to invoke the appropriate command on your computer. All right, which is we do from the keyboard. So let's go ahead, and this is going to be our defective cluster here, and this one is going to be our target cluster, our replacement. Okay, yeah, they're different, but this is just for demonstration purposes. So what I'm going to do, I'm going to take the data from this EEPROM and put it into this EEPROM. Okay, so I'm going to push this over the top of the part, like so. I'm going to go back to the computer screen. I'm going to press Quick View. There's the data. Okay, so I know I'm hooked up to the part. Hit a key, I'm going to hit G, and we're going to get that data. Okay, there's the data from our source our defective cluster. Let's move over to our replacement. Put the AccuTouch probe over the top of the part. Let's make sure we're connected. Press Q. And yes, we have data. Let's do it again. Quick view. Device contents. Okay, now let's program it. To and yes. Okay, so what we just did was we cloned this cluster, we read it, moved the probe over here, programmed that data into this cluster, now we're done. Okay, so you can see with the AccuTouch probe, it's even faster than the clip. And that's one reason that we have this. The other thing that it lets you do, as I said, when I do the reading of the part, I just put the probe on, hit G, read the data, move the probe, hit 2 and yes, and I program the data. That's it. That's all you have to do. Okay, so one other thing I want to point out to you, let me flip back over to the computer screen. If you look here, I think it's this one. I didn't point it out on the GM. I think this is your VIN here. I'm not familiar with. VINs are 17 characters. So each line is 16. So we're missing 2. So that would make this 15, 16, 17. I don't know that the 2 is part of the VIN or not. But anyway, if you wanted to edit the VIN, you could easily do that here. So that's how easy it is to work with the AccuTouch probe. And I just wanted to do the Volkswagen clusters to show you that, you know, it's not just for General Motors. Anybody who manufactures a vehicle, a module, a cluster, whatever, with the eeprom, you can use the Automotive Kit 1 or Automotive Kit 2 in order to clone or edit the data that's in the eeprom. Okay, so that shows you how easy it is to do a Volkswagen cluster, or any other cluster for that matter. So okay, the last thing I want to show is a cluster which doesn't use an 8-pin eeprom. So we'll do that one next. Okay, in this next part of our demonstration, I'm going to show you how we use this is Automotive Kit 2. Okay, Automotive Kit 2 includes the ACOM2 adapter, which allows the system to communicate with Motorola microcontrollers. This is the Motorola microcontroller here. The mileage is stored in eeprom inside the processor. Okay, so in order to communicate with this is not the same as an 8-pin eeprom. We have to connect to this part, we have to set up a little communication link with it, and then we read it, and then we program it. Okay, so in order to do that, there are additional steps involved, but I want to show you how that works. I'm not going to take the time to go through connecting the probes and all that, but I will show you how we know where those probes go and how you will know what to do. Okay. Quickly, this is out of a Ford F-150. I think it's 1999, 2000, 2001. I'm not sure what year it is. But the designer chose to use a microcontroller, a Motorola microcontroller, rather than an 8-pin eeprom. So we provide with our kits, both of our kits, Kit 1 and Kit 2, what we call the surface mount probe set. And for people that wonder why we provide the surface mount probe set, well, there are times when the clip, or in some cases even the AccuTouch probe, cannot get to a part, or you want to connect to other points on a circuit assembly, or you want to connect to a microcontroller, and that's why we provide the surface mount probes, so that you have that option. Let me zoom in so you can see exactly how these probes work. Okay, here we are zoomed in, and the way the probes work is they have little teeny jaws. so I can get this one off and show you. Okay, see the jaws come out the end? Well, those jaws then retract and attach to the appropriate lead on the component. And how do you know which pins to hook to? Okay, well, we tell you that. First of all, let me point out something else. This is a Motorola microcontroller, but it does not have a Motorola industry standard part number. They use what are called mask numbers, and the mask number is right here, where it says E22B. All right, the 3 is not relevant. A mask number is always an alpha character, the E, followed by 2 numerics, 2, followed by another alpha, which is the B. So E22B. Well, we give you a cross-reference sheet, and it's also, there's one built into our software, which will tell you what that particular industry standard part number is. You can also see that Motorola was kind enough to print forward on the part. And you can see that the date's 1997, so this is relatively old. But, you know, cars today live forever. So in the event that you have a cluster that has failed, you can clone into a functioning cluster the same way that you would clone something with an 8-pin eeprom. Okay, so how do you know where to attach the parts? Well, let me show you what we provide. Okay, this is part of the package that comes with the automotive kit too, comes with the ACOM adapter. As I said, we don't leave you trying to figure things out on your own. You can see that each one of the pins has an identifying probe color to which that is attached to the part. So you just hook up your pins, your probes to the pins as they are identified in this particular diagram. And we have other diagrams for other controllers, other microcontrollers on the document that we provide, but this is the one for this particular microcontroller in this particular cluster. So that's how you know how to hook up your probes to the part itself. Okay, now before we proceed, this is the ACOM2 adapter. Okay, ACOM stands for asynchronous communication. It's included with kit number 2. It's not included with kit number 1. However, if you buy kit number 1, and what we recommend is if you want to put your toe into this pond where you're working directly with memory parts and modules, start with kit number 1. Unless you know you'd just like to have kit number 2, because you can always upgrade kit number 1 to kit number 2 simply by purchasing this adapter. Okay, but this adapter goes into the programming unit, and it allows us to set up a little communication link with the microcontroller, which is in this case on the cluster. Okay, so here's the adapter installed in the programming unit. We have a oops, a loose wire here. An expansion option on our system, our programming unit, which allows us to create adapters which require additional voltages, currents, or signals which are not available from the socket. And the ACOM2 uses that. That's what the little orange and yellow umbilical is there that connects to the accessory connector. And the way that it works is bring the cluster over here. This is the connector on the end of the cable to which the probes are attached. And what you do is you press this into this connector here, and that's how you connect the probe set to the pins on the processor. And then when you're ready to work with it, okay, you push this switch here over, and you'll watch. If you notice, the red LED lights on the ACOM2 indicating that the cluster microcontroller now has power. Okay, you don't want to hook the probes up with the light on because you're hooking it up hot, and that's not a healthy thing to do. Okay, so you get it all hooked up properly, you turn on the ACOM2, and then I'll show you the next steps. Okay, I'm going to position the cluster here so you can see it there. All right. Now I'm going to go back to the computer screen, and we're going to change the device type to the Motorola microcontroller, and from our cross-reference list, the E22B mask is actually 68HC11E9 microcontroller. Oh, I need to get that. Let's go back. Command 9. 68HC11E9. Okay. And you'll see it says requires a COM2 adapter. It shows you how to set the dip switches on the adapter. It shows you how to set the dip switches on the programming unit. And at this point, we are ready to read the information from the Motorola microcontroller. But in order to do that, we have to communicate with the part. So the way that we do that is we use a function in our software called device options, which is Command Z. Okay, so I'm going to press Z. If you look there on the screen here, it says device options, because this is a microcontroller and it has options. So you press Z, and you turn on the AccuTouch before you press Z, otherwise it says the AccuTouch is not responding. Press Z, and we're going to choose option 1, upload 68HCXX communication program. Okay, you can do other things with the AccuTouch, but for the purposes of this demonstration, we're just going to do a clone. So we're going to press 1, and it's going to upload the communication program, tell you that the communication uploaded complete. Then it says communication verified. It must say communication verified. If it doesn't say communication verified, then you will not be communicating with the processor, and it will come up and it will say communication failed. Okay, at this point we now are communicating over the cable to the microcontroller on the cluster. Okay, and you can do the same things that you could do with an eeprom, regular 8-pin eeprom, you can now do with the microcontroller. So we'll go to Command 5, and we will press G for get valid data. And it's reading the data, it's comparing the data, and that's the information that's in the eeprom on that microcontroller. Okay, I didn't see any mileage, which was easily discovered here, but anyway, it's got to be here because that's what they stored it in. Anyway, if you look up here, it says device size 0 to 1FF. Okay, well that's the device size in hex. All right. So if we go over here, we go 0, 1, 0, 2, 0, 3, 0. These are the addresses for each line here. And if we end at F0, but if I press the down arrow key, you can see that we now move into the second part of the EEPROM array inside the microcontroller. And you'll also notice when we get down here to the bottom, 1FF, that's the last line, that the number 200 is no longer turquoise, it's now magenta. Okay, what that indicates is this is the end. This would be another part. If you had multiple parts and you were, not that this applies to automotive or digital cluster work, I can't apply to automotive work. But if you're working with video games or things that have multiple EEPROMs or multiple memory chips, it's nice to know where the boundaries are. So that's what this is. This is a boundary indicator. That's why it's changed color. Okay, actually this may be mileage over here. Now that I look, where it says and 3, it's 263326. It's stored in 4 places instead of 3, but that may be mileage. I don't know. Anyway, I wanted to show you that. So now we've read the data from the EEPROM in the microcontroller into the system. Okay. Now, at this point, I would suggest that we save this. Okay. The reason is, yeah, you can go ahead and just move it up in memory and save it. But since this is a microcontroller and you are communicating with the microcontroller over a little communication link, and you want to move this data into another cluster, when you disconnect the probes and then connect them to your target module, you're going to have to reestablish communication. And when you reestablish communication, when you upload the communication program, you will lose this information. Okay, So what you need to do is save it. So I'm going to save it. Show you how to do that. I'm going to press escape. I'm going to set our path, which is where we're going to be saving things. Oh, I have one cleverly named clusters here. So I already have one named clusters. So we're going to press clusters. Then I'm going to go to the librarian and see what I've got. No display, small display. Okay, well, let's make one. I'm just going to do it in the directory command. I'm going to press D for directory of files. So we're just going to call this Ford. Ford, F-O-R-D. Ford 150. .bin. Okay. So we use Command A, and it'll say enter file name. I'm going to press insert for recall file name, and there's my Ford F150.bin, and I'm going to press enter, and it'll say save defined range. You'll notice that the defined range is the size of the part, eeprom array 1FF, and we say save. File save complete. Now we can go back and look, and you'll see that we have right over here, Ford F150.bin. Okay, now, what I'm going to do is, I don't have another one of these clusters. I only have one. Okay, so I'm going to clear the data. Actually, let's just program in one of our test files so you can see it work. All right, basically, the point I'm trying to make is how to use the automotive kit in order to work with a microcontroller-based cluster. So what I'm going to do is I'm going to go to path. I'm going to go to, we have a file that we provide for testing if you choose to do it, directory called test file right here, and I'm going to load it by pressing F4. And it's an 8K file, so it's much larger than the EEPROM capacity of this part. But it doesn't matter. Here's the test file, okay? But it goes down to, if you look, there's the boundary, okay? So we're only going to go from, we're going to program from here up to the beginning. All right, so we'll do that. We're still communicating. You'd have to, okay, the point that I want to make is you'd have to connect your other cluster, reestablish communication. I'm not going to do that. I'm just going to leave this already attached and communicating so you can see it work. Now, you know, let's not do that. If we're going to do a demo, let's do the correct demo. All right, I'm going to turn off the ACOM. I'm not going to disconnect the probes, but the ACOM is now off. So the part itself still has its original EEPROM contents, okay? But now, I'm going to go back to the main command list, and I would, when I put my target cluster on, I would have connected the probes, hooked it up to the ACOM2, and now I'm going to reestablish communications, Z1, okay? So now I've reestablished communication, all right? So let's go ahead and program our test file. Directory of files. Test file.bin. Load it. Go to the buffer. I'm going to press 2 and yes. And it's now programming the data over the communication link into the EEPROM in the microcontroller. Okay, so let's clear this and let's reread the microcontroller. Okay, so what is in the microcontroller should be our test file. There it is. Okay, so we've just, in essence, destroyed the data that was there representing what was in the cluster previously, and now we're going to put the information back So you can see how we would clone that back into the cluster. I hope I'm not confusing you, but let's just do that. We'll clear this. I'm going to go back and I'm going to find clusters, and I'm going to press directory of files, selected directory of files. And here we have Ford F-150.bin. Okay, we're still communicating with the part, and I'll show you how easy it is to put that file back. If you look down here, it says F3 to program. So I got my file highlighted there, so I just press F3 and then I press yes. Program, or shall program. Now we're programming the original file back into the part. So let's go back to the buffer editor. Okay, there's the file. Let's clear it. And now we'll press a G and reread it to show you that the file has been basically restored. Okay, that's the original file that was in the microcontroller before we changed it to our test file and then restored it. So that's how you would clone. The steps are a little bit, there's a few more, but basically it is connect to your defective cluster, read the image from the eeprom in the defective cluster and save it to a file. Connect to your target cluster, establish communication, and then program the data which you saved from your original cluster into your target cluster, and you're done. Okay, this is what Automotive Kit 2 allows you to do. And in this case, I've shown you a Ford F-150. Mercedes uses Motorola microcontrollers, Saab, and others. Okay, so the ACOM 2 adds the Motorola microcontroller technology family to the kit. And that's the point I was trying to make. Hopefully this wasn't too confusing for you to follow. But I did want you to see that you can use the Automotive Kit, in this case Automotive Kit 2, to work with the Motorola microcontrollers to do the same kind of cloning that you could do with an 8-pin part. Okay, well that wraps up what I wanted to demonstrate with respect to using the Automotive Kits to work with digital clusters. Again, we provide all the documentation that you need in order to know where to attach the clips. We also, with our kits, provide a training tutorial with it's an 8-pin eeprom, so you learn how to use the product before you begin working with modules. It's kind of rare today to actually find a company which provides training with their product, but we do. So if you found this demonstration, this video, helpful and informative, and like the content, please like our video, and you can subscribe if you choose to do that. But I guess the thing that I would request you to do is, if you are interested in our products, we would certainly appreciate your business. We are not a big company located in China. We're a small company located in Ohio, and we would very much appreciate any businesses you could send our way. The other thing that we do is, if you have a question or a problem or an issue, we have a phone number, not just an email address, but a phone number. And you can call us and you can talk to us. You can talk, actually, many times, you'll talk to me. So that pretty much wraps this up. We appreciate the time that you have invested in watching this video. And again, if you want information on our products, or if you would like to order our product, that can be done from our website, which is arlabs.com.